from the mechanical engineer department at the University of Auckland, come here to give us a seminar about Industry 4.0 and 5.0. Actually, Professor Xu is the chair professor in the Department of Mechanical Engineering, and his research focused on the intelligent manufacturing, and he worked this area for more than 30 years. He is one of the most prestigious researchers in the smart manufacturing field in the world. Has been awarded as the most among the 20 most impact researchers in the area of the smart manufacturing. And today it's an honor for us to invite Professor Xu to give us a talk about I think he also recently published a paper in this area. So he wants to give us a talk about what's currently we are in the digital revolution of the Industry 4.0. But I think in the next 10 years, we are going to have another revolution, and it's about Industry 4.0. So Professor Xu will give us the talk on that. Let's hand it over for Professor Xu, and yeah, can you share your screen and maybe can give us a talk? Thanks.
Right, thank you, Yulong, and thank you all for coming to this seminar. I look a bit different, do I? Okay, that's all right. Yeah, yeah. Monash is not strange to me. My second daughter graduated from here, but she didn't do engineering, in spite of my encouragement. And that's all right. So my talk today is actually the title of the paper that we published recently. I don't know whether you've read my paper. Anybody sitting here, have you read my paper? Okay, all right. Well, that's cool. I can. Yeah, it is open source, so you can view online for free. Now the topic is Industry 4 and Industry 5, inception, conception, and perception. I don't think many people know about Industry 5 yet. Industry 4, sure, people know this for some time. I was tempted to actually add another line to my title, which is misperception or deception. So if you like, but I didn't have these two words in my title for the paper, of course. It can be a bit of a problem if I have them in there. So what I do is usually when I give a talk, I talk about research work in my laboratory back in New Zealand. I'll probably still do that briefly. Then I want to cover the genesis of this paper has been published last month. Oh no, in October. This is December now, is it? So I come from New Zealand, and I've got a homepage down here. If anybody's interested, then go and visit my homepage. I will work in the laboratory called Laboratory for Industry 4, Smart Manufacturing Systems. Okay, so I'll talk about our research in this area, but perhaps not everything we do. I'll just give you a snapshot of the research we do in the lab. So the agenda for my talk today will be, will be the paper itself, as I mentioned. Then I talk about the research work in our lab, which is LISMIS, which is the abbreviation for the lab. And I'll probably talk briefly about international perspective as far as Industry 4 is concerned. Then the key content is Industry 4 and Industry 5. There are some questions in that paper. I'll go through that here as well, and some discussions, and finish off with some final words. So the paper is this one. as you can see, it's public available online on the 18th of October. So that there are 4 authors there. It's published in the Journal of Manufacturing Systems. So the paper itself, this is August when Delta variants hit New Zealand. So we went back lockdown level 4. So basically, give me a good time to write the paper. So 2 months, I basically took it to write the paper, the majority of the paper. Then in collaboration with the other co-authors. So it was submitted on the 27th of September, came back with a minor revision on the 4th of October, and then we quickly revised it and submitted and got accepted on the 8th of October. And then became online 18th of October. So if you like, about a week, the paper was accepted, and about 3 weeks, the paper is published online. So we wish all the other papers we write will have a short journey like this one. Anyway, so that's the paper, the inception of the paper. Coming back to one of the key topics, Industry 4, and the diagram is not foreign to many. You've seen this before. You can see I spell industry as in a German way because the diagram came from Germany, and also the concept, the terminology was originated in Germany. So it is a German vision, but quickly picked up by people from different countries, of course. Just to summarize Industry 4, it is a high-tech strategy from Germany. And what it is, well, still debating, I think, what Industry 4 is essentially about. Well, I think there's some key things there we need to be aware of. It is actually a collection of contemporary technologies in manufacturing, in automation. Things that it embraces doesn't mean that those are brand new, and things like IoT, we have it for a long time, and iOS, data analytics, we've been doing this for years. Cyber physical system, that itself is not new either, came out of the US. But I think what it is trying to pull together some of the contemporary technologies to see whether it can elevate manufacturing and production into another level. And in Germany, they actually have it as a dual strategy. So one is looking at domestic market, which is in Germany, they still want to be the leading market. So this is looking at supporting domestic production. We don't actually hear that much because all we hear is the second purpose, which is wanting to become, continue to be the leader in technology supplier area fields. So this is really what we hear, what we know about. Is the ambition still Germany wanting to be the major exporter for technologies and products. So I think so this dual strategy sometimes bothered people in European Union in general as well, because they think, hey, that's your national strategy. Why do you portray it as a sort of industrial revolution? But that's the way it has been. I think this one thing that's very clear, Industry 4 is a technology focused initiative. So it does has a strong emphasis on technologies. So that's the main feature, if you like. Well, if you look at Germany, different places in Germany, there are different initiatives coming out of this Industry 4, some actually pre-Industry 4. So there are two things that has happened in the past. And one is the learning factories that are established in different places in Germany. Another will be specific Industry 4 research projects working with local industry. This diagram, this picture is a bit dated. I think there are actually a lot more to this so far. So that's German situation. But if you look at the initiatives around Industry 4 from different parts of the world, clearly it's very easy to see them. It's catapults in the UK, Sweden, made in Sweden 2030, in the US, Canada as well, and China, of course, and Japan and Korea. And in Australia here, I think if you remember 2017, there is a Prime Minister's Industry 4 task force established. I think now it's called a different name. And in New Zealand, so we also have some initiatives, and we set up our laboratory as well. So this is how it started in Australia. This is a agreement signed between Germany Platform Industry 4 and Australian government. So there are 5 initiatives, streams, if you like. You can see it does focus on small, medium-sized enterprises. It looks at architecture and standards, testbed as well, which is something quite interesting. We're watching with interest in New Zealand. So the testbed actually so far, most of them have been established. As you can see there, there are 2 or 3 in Melbourne. There's 1 in Sydney, Queensland, Adelaide, and Perth. Oh, there's 1 in Tasmania. So the idea is testbed is there for both research and supporting industry. But what is, how does it look, Industry 4 in a factory? So there are many debates. One of them is to look at how a factory can become adaptable and reconfigurable. Because one of the key drives for Industry 4 is really looking at mass customization. How do you produce products which suit individual needs and to support this low volume, high mix production scenario? Well, one way to do this is to make sure that your factory is reconfigurable. You can easily adapt to the customer's needs and different products and small batches. And then there are a lot of smart factories which established since then. And this is the one that's established in Kaiserslautern in Germany. So what you see here is 4 workstations. They perform different functions. So the one to the right is a machining center. Then you have a mobile robot there, and for handling jobs. And you have this could be an assembly workstation, and then there's the inspection workstation as well. Now these workstations, they're mobile. You can move them around. You can reconfigure them. Once you do that, it knows what it can do by itself. So there's sort of communications between different workstations. Clearly, they're not connected through cables or anything like that, and they are wirelessly communicating with each other. So we've done some work in this area, explain quickly about this. So it's reconfigurable and flexible, and it's not controlled by PLC, and that's also an interesting thing there. It's by service-oriented control system. And the product itself actually drive the system. So in other words, the product has got a RFID cards. So you scan it and it tells you what this is to be made of and made to be. And then it will drive the process. An operator will be assisted by some technologies like augmented reality. So you scan the workstation, and on your phone, you see the current status of the workstation and what it's doing, what it's capable of doing. Now, one perhaps has to go as far back as looking at RAMI 4.0 to really look at how such a factory can be set up. We're really interested in this dimension. This is a reference architecture model industry 4. So looking at factory hierarchy, and if you look at the whole factory and you have products you're making, you have different devices, control modules, different workstations, and then they connect it in, to the outside world. So this diagram to the right is really trying to describe a factory that is as flexible as you can think of. So if you think about factory, it has got all different equipments and devices and control units. And this is how it looks, and you can actually piece them together in whatever way you want, and then they communicate with each other, and they know what they can do. So really, we flatten the whole structure. I don't know why it's doing this. So we're looking at a smart factory. We really have to rethink a factory as a rigid shop floor. All the equipment are fixed for life, and the only thing moves are the operators and robots, AGVs. Now, how do we do this? So really, one of the key things is to look at communication methods for this type of smart factory. So if you look at the factory, the business layers there, if you look at the communication layer, and this is the factory hierarchy there, really the communication layer has got, if you look at the OZ layers, there are 7 layers there. So these are the things that we're looking at in terms of supporting factory communications. And our focus is this green bits, OPC UA, open process control, unified structure. So we've been doing some work and using that protocol to support smart factories. Now, smart factories, as I mentioned, it is about workstations and machines communicating with each other without having to have cables connected or any restrictions. So we're looking at machine-to-machine communications, which is different from typical communication. And typically we communicate, usually the machines will communicate with an application or a server, and server will oversee and manage all the other machines centrally. So this is really trying to devolve the communications into individual machines. So the diagram down here is essential for smart factories. So we've looked at this and we've done some work in this area, and we think the key enabler is OPC UA. So this is sitting at the intersection of Industry 4, IoT, and machine-to-machine communications. So we use OPC UA, and if you look at the communication methods, and it's got different modes, OPC communication modes. We've been looking at different type of modes. This one is a client-server mode, very common type of communication. The server will be responsible for gathering data from the devices and then provide the data for a client to consume. So client will request and the server will provide the data as needed. So we look at this type of communication methods. How it works, this is a setup in our laboratory. You can see there, there's a machine tool there, it's robots, 2 robots. There's a circular conveyor, there's a linear conveyor as well. So it's like a mini factory, if you like. So you have your product coming into the linear conveyor, handled by the robots and perhaps placed onto the circular conveyor, and this robot will pick up and load it to the machine tools and get it machines. What you don't see is there's actually an assembly workstation to the right, and when it's finished, a bit of inspection and before it's assembled. So we developed an architecture to support all different equipments behavior as machine-to-machine communications. So if you break down the whole thing, and so these are different units, linear conveyor, Cooker robot 16, circular conveyor KR10, and the machine tools there. So what we try to do is to try to go into the control system and look at the controllers of the robot and the machine and the conveyor system, trying to use OPC UA to support communications. The way it works is all the controllers will have a driver, and we need to set up the server for all of them. And then you can actually use clients to access the information from different servers. So what we did is we developed a Cooker OPC server, National Instruments OPC server as well. And for this little lathe, we couldn't have a ready developed server, so we used Python, develop a server ourselves. Then you can develop different clients to communicate with the server to access data coming from the server. You can write different applications to consume the data. Same you can do for the NI controller and also for the Cooker robot controller. Notice that I've got NI OPC clients to access both Cooker robots and NI OPC server as well. This is because they all speak the same language. So that's the beauty of OPC, OPC UA. So very quick run about what we've done in that enabling a smart factory and how it may work. And OPC UA, remember it's going to be a critical communication protocol for Industry 4. I want to come back to this diagram because we are talking about Industry 4 and Industry 5. So it's time to bring Industry 5 here. And so we haven't quite finished the 4th industrial revolution. And here comes Industry 5. So it does raise questions. How do we understand the situation? What's the landscape that we're looking at? Does it change Industry 4? Or what is Industry 5? So I just want to quickly walk you through my paper. So it's a lot actually repeating from what's in the paper. So the paper is open access. So if you Google the title, you'll find it. You can download. We paid how much? $4,500 US for the open access paper. Well, not all papers on open access are published. This is perhaps one of very few. Now, it's important to actually stand on a unbiased field, unbiased ground to talk about these two different terms. The way to do this is to make sure you have the right literature, and the literature has got authority and credibility. For Industry 4, we mainly use these two documents. They are online, available to all of us. So they're coming from Germany. But the one to the left is perhaps the most relevant one. So if you want to know more about Industry 4 in German terms, this is in English, of course, and go and Google for these two documents. And for Industry 5, clearly is quite new. There hasn't been a huge amount of literature about it. But we do restrict, there are some publications and some non-mainstream publications from minor journals, if you like, and conferences. But we have decided to rely on these two key documents about Industry 5. So go and have a look at Industry 5 in these two documents if you are keen to know more. What this is early this year, and the European Commission published these key documents to fully define Industry 5. And hopefully research will follow. As a matter of fact, there's a lot of initiatives already established. I think European Union has got a funding course for Industry 5. So that's the source of our paper. But what is Industry 5? It is understood to recognize the power of industry to achieve societal goals beyond jobs and growth, and to become a resilient provider of prosperity, and look at the boundaries of our planet and the well-being of the workers in industry. So you can see that it's really very sort of goal-driven concept. It doesn't emphasize technology. So you won't look for technologies in this definition. Well, that's not my definition. This is the European Commission's definition. So a diagram which perhaps is more accurate to depict what's the core value of Industry 5. It's a human-centric concept. It's very important. Put human in the center. Human here meaning the operators and the workers and working in the factory, and also perhaps the general public. Resilience, and we all know what resilience mean these days now, and sustainability, environmental aspects. So when I saw this, I asked myself, is this a revolution, or is this industry revolution, or is this a set of goals that we need to achieve? Together with some kind of industrial revolution that we're talking about. Okay, so we set out to look at these two terms. Perhaps one can conclude with little debates that Industry 4 is technology-driven and Industry 5 is value-driven or goal-driven. And it does mean that there are two industrial revolutions happening at the present time. Now, you may or may not have problems with this. I have a bit of problem with this. We will see why that's the case. So there will be questions, there's no doubt about it. And so I've decided to try to write a paper to try to answer 5 questions there. The first one is, well, Industry 4 is technology driven. So just how, to what extent is technology driven, and to what extent is is a biblios of industry of human-centric and sustainability and resilience. So that's first thing, and clearly, it's perhaps not a black and white situation, and one would like to think. So we would have a look at that in a minute. Second question is, can Industry 4 embracing enabling technologies also help realize the goals of Industry 5, or do we need some new technologies developed for Industry 5? So that's also an important question, you know, and if say, look, Industry 4 is good enough to support Industry 5, then it probably will sit well with people thinking about two industrial revolutions. A third question is perhaps surprisingly easy to answer. That is, Industry 4, is it a chronological continuation of Industry 4? Similar to their predecessors. So it's 5 a continuation of 4. You know, we've got Industry 1, 2, and 3 up till now 4, and so there's a clear linear kind of progression. So we want to have an answer to that. If that's the case, perhaps don't talk about Industry 5 as yet before we fully realize Industry 4. And we talk about two industry revolutions coexisting at the same time. Well, what about thinking of, we probably only have one industry revolution, and we don't use Industry 4, we don't call them Industry 5, maybe we can call them a different term. Maybe it's a techno-social revolution. I think that makes sense as well, because if you look at Industry 5, look at social values a lot. And then you have technology. So we try to bring these two things, which can be at odds with each other. Now we think they probably should be considered in the same pot. A final question is, what would industry's journey of Industry 4 and Industry 5 look like? Now, this is very important because we've been working with industry, and some of them have already started, you know, looking at Industry 4 technologies. They're on a journey, and there's a strategy for their business already. Then along came Industry 5, so they have questions, you know, what is it? Well, when we started Industry 4, you know, we only started setting up the factories, you know, IoT environments, whatever, and looking at the data collection, data analytics. So what? You have Industry 5 now. I think we owe industry a clear statement about Industry 4 versus Industry 5. So these are the 5 questions, and I was thinking about, you know, what sort of question. I think these are perhaps the most common questions people will ask. So I'll just quickly explain some of the rationales we have got in the paper and how we actually came to trying to answer some of these questions. I don't claim to provide crisp answers. I don't think I can. I don't think there is. There are crisp answers to these questions. What I will not talk about will be the definitions of revolution versus evolution, because there's a discussion about Industry 4 is actually not a revolution, but evolution. That's fine. So we're not getting into that sort of discussion. We are not either trying to provide a unique definition for Industry 4 and Industry 5. So we're not into that business either. Otherwise, the people will be double the size. So we're not doing that. And we're trying to answer some of these questions, but don't expect a clear yes or no answer. Now, quickly look at Industry 4. Remember, I showed the 2 key documents online. So what we did is we accept Industry 4 is technology driven, yes, but do we accept that it ignores issues like sustainability? It doesn't talk about resilience. What about human-centric? So we want to know a bit more about this under Industry 4. So what we did is we just go into those documents. So very easy to do. You just search for human-centric, for example. You search for resilience. You search for sustainability. And surprisingly, it came out. There are a number of occurrences in those documents. So that tells me I don't think Industry 4 is ignoring these topics. Well, it's not putting that as a central issue, of course, but it's not ignoring that. So just to quickly explain this. So Industry 4 does address challenges with resources and energy issues, urban production, social needs, and all the related sort of resilience topics. And also the second point there, and so Industry 4 was, of course, it's pre-COVID and has got, the document has got a number of example applications. One of them is called sudden change of supplier during production due to a crisis beyond the manufacturer's control. So we have situation now, do we? Supply chain disruptions before COVID. Well, I don't think they foresaw the situation. I don't think so. But that does mean that people back then did think about situations like this. Human-centric under Industry 4, does it do anything about human-centric technologies? And well, I think the answer got to be yes. And you know, the technologies like human-machine interactions, robot-assisted systems, augmented reality as well. That's all under Industry 4. So I think it does address human-centric, human-centricity, I think. And the work upskill and the reskilling workers' well-being as well. So that's Industry 4. So we sort of understand it's not purely just technology, but it does try to address issues, social issues, and human-centric and resilience matters. Industry 4, Industry 5, as we just briefly discussed, it looks like societal goals. Okay, look at the well-being of the factory workers and respect the boundaries of our planet. So basically, the three key values. And what it also does is it's trying to take a more systematic approach rather than a technological approach, individual technologies, and develop it and then support industry. So that systematic approach perhaps is new. And what it also says is Industry 5 down at the bottom complements the existing Industry 4 paradigms. Now, this is acknowledging Industry 4, saying we're not superseding Industry 4, saying we still need Industry 4. But that helps solve some of the, well, clear some of the cloud, I think, if you like. But Industry 5 technologies, enabling technology, if you look at Industry 4, there are some enabling technologies we are familiar with. And if you remember that diagram that Boston Consulting Group put up, there are 9 enabling technologies for Industry 4. This is the Industry 5 enabling technologies from that European Commission document. Well, I won't read this. If you read this, if you look at them, perhaps most of them actually already in Industry 4. Things like human-machine interactions. Well, it emphasizes individualized. So yes, I think that's just to what extent you have your interactions. Artificial intelligence, of course, and bio-inspired technologies, and smart materials for recycling purposes, energy issues, digital twin and simulation for the entire system, data transmission, storage, and analysis. So you can see, yes, it's addressing those key values, but when it comes down to technologies, there's a lot in common with Industry 4. So there's no question about that. So that basically, well, makes sense that they're saying Industry 5 complements Industry 4. Just another diagram to show the enabling technologies for Industry 5. So let's see, virtual worlds and physical worlds, and somewhere in between virtual and physical. But if you look at these key words, and they're not new. They already exist a lot of them exist in Industry 4. Okay, now come to the 5 questions. So just trying to answer these questions. Industry 4 is technology driven, but is it oblivious of industry of human-centric sustainability or resilience? Perhaps the answer is no. Yes, it does have a technology slant, no question about that. But I think it does it still address some of the issues of human centricity and sustainability and resilience. But Industry 5, they have a focus which is looking at systemic approach, looking at system level rather than application level. Second question, can Industry 4 enabling technologies also help realize the goals of Industry 5, or do we need to develop new Industry 5 technologies? I think if you look at the Boston Consulting Groups, the 9 key technologies under Industry 4, compare with the ones that's in Industry 5 documents, many are actually the similar technologies. Only some, perhaps a handful of them, are more Industry 5 related technologies. So this perhaps is telling us that we still need Industry 4, even you want to talk about Industry 5. Question number 3, is Industry 5 a chronological continuation of Industry 4, similar to their predecessors? I think if you read Industry 5 documents and papers, it does claim it is not a chronological continuation of Industry 4. So it actually complements Industry 4. It's natural extension of Industry 4 into areas of, well, then it is also debatable. If you look at research around Industry 4, I think we already start to address those issues. Even you don't talk about Industry 5, we're still addressing energy issues and environmental issues, resilience issues as well. So the question is it appropriate to call that Industry 5, or maybe it's a Industry 4 plus or Industry 4.5 or whatever. But that may or may not be, we may not go down well with certain people, certain groups of people. Typically, people hate jargons. If you have jargon, you don't create a jargon for the sake of having a jargon. I don't like jargons either, so we have a problem in this situation. Question 4, are we living amongst 2 industrial revolutions or effectively one, which is called techno-social revolution? Yes, we all acknowledging these 2 revolutions happening at the same time. One is technology driven, another is value driven. But I think if I were to given the task to name this revolution, I would just call this techno-social revolution. You know, and let's don't confuse people. Let's don't confuse people from industry. If people like us are confused, and think about people in industry, how can we convince them? Final question: what would industry's journey of Industry 4 and Industry 5 look like? Clearly, as we talk about this, we don't want to create confusions for industry. Well, what is perhaps true is industry perhaps need to repurpose or readjust the journey of Industry 4 and thinking about the key values promoted by Industry 5. And it is not two journeys, it's one single journey for industry, for business. So I think that's very important for business to recognize, acknowledge this. Okay, I'm finished now. And final words. So if you look at industry revolutions, typically it's driven by key technologies, okay, transformative technologies. And they often lead to fundamental changes to industry, but also to society that we live in. So, and that is a typical industrial revolution. But if you look at Industry 5, perhaps it's not that sort of animal, if you like. Industry 5, therefore, to say is not a conventional term of industrial revolution. It's different from 1 to 4. So I think this will be a fair comment. So that's what I have in the paper at the end. It is true we can say that Industry 4 needs Industry 5 to be reminded for those essential societal goals and needs and the values and the responsibilities that we all have. But Industry 5 needs Industry 4 for technological pushes and solutions. So really they can't be separated. They basically just one thing. So I like to think of them as one thing, it's one revolution. But that's just me, a single voice. A few more thinking here. As I said, some people like buzzwords, and they can be useful when applying for funding, for example. But we run the risk of having, this long list of buzzwords coming to us. Industry 4 plus, Industry 4.5, and maybe we have Industry 6 before too long. Industry 7, or do we want that? Clearly we don't. Please don't play with these buzzwords. We do not want them. We need cool heads and a wise mind. So the paper basically at the end just try to encourage discussions and debates. So I think we still need to discuss this and debate about this. Two revolutions happening at the same time may not be very healthy for certain environments, but it can work out well and work out beneficially for the society and the industry, in my view. So hence, coming back to my title, Inception, Conception, and Perception. Well, I did talk about the original thinking of Industry 4 coming out of Germany. I think they were looking at domestic industry markets, and then they think we got to push it into international arena. So, and then this perception of Industry 4. Industry 5 came along, and what people think about it, what we do not want to see is a lot of misperceptions about these terminologies. We certainly do not want to have deceptions. So the final two words are cautions. We probably do need cool heads, as I said, and wise minds. Okay, so that's me, and thank you for your attention. I guess happy to take any questions as the purpose of my paper, have discussions and debates about these terms. Okay, thank you.
Thanks, Professor Xu, and for your very interesting and fantastic presentation. Give us a very quick, brief idea about what is the Industry 4 and Industry 5.